present our host, to introduce our host, Mr. Yogesh Patil sir. He has done a bachelor's degree in mechanical engineering and he has done MBA in operations management. Okay? And currently he is working as a senior engineer in Gunego Private Limited. And earlier he was a former lecturer at Parul Polytechnic Institute. So he will be giving webinar on need of additive manufacturing and 3D printing. Okay, so I welcome Yogesh Patel sir once again, and I request him to represent his webinar. Thank you.
Okay, thank
Over
you,
to
Poonam.
you, Yogesh sir. Yes.
Am I audible to all?
Yes, you are.
First of all, thank you, Parul Polytechnic Institute and Parul University for giving me this chance to represent myself. So today's topic is additive manufacturing and 3D printing. So we will going to discuss what is additive manufacturing, what are its effect and impact in industry 4.0. Hello. Hello.
Yes,
So
sir.
this is a need of additive manufacturing. Ma'am already given my introduction to all of you. So should we proceed? First of all, I would like to explain what is additive manufacturing. So this technology is from since 1980. The first concept introduced in Sweden, and the name was rapid prototyping. So during any design, during any change, whenever we are thinking to produce new thing. So I am particularly in new product development, working as a R&D engineering. So before starting this, we need to what is rapid prototyping. So before putting anything into real manufacturing, we are doing rapid prototyping to check its feasibility. So how to do the rapid prototyping? For rapid prototyping, we have one new concept, that is additive manufacturing process. So in additive manufacturing process, we are adding material and producing the objects. Like that, we are producing the objects. So this is the basic definition of additive manufacturing. You can see on the screen, objects is created by adding layer by layer, whether it is plastic, whether it is material. So this is a 3D printer which produces the object. So basically we can define additive manufacturing as it's a process of joining sequentially building material in successive cross section, one stack upon another, or in short we can say that material is added by layer and object is created. So this the process is known as additive manufacturing or 3D printing. Okay, so material may be plastic or it may be metal itself. So we will discuss the type of material also in next slide. So next is this is a 3D printer. So the equipment used to produce additive manufacturing object known as 3D printer. In 3D printer we can see this is extruder, this is hot end. So we are supplying plastic. So plastic is connected over here through filament extruder. So this extruder melts the plastic over here by heating that material, and hot end this molten plastic will deposit it over here. So these are the beds. So this bed is moved like this, whatever arrow I shown to you. So this is vertical moment and this is cross sectional moment. So for producing the 3D printed object, we should have one CAD file also. So by using CAD file, we will produce the 3D printed object. So before starting producing any object, what are the factors we are going to consider? So first factor is we need to do feasibility study, cost, volume and time required for producing that material. So what is feasibility study? For producing any object, we should have a strong background. What is aim of producing that object? So we will say that feasibility, how much is feasible. So in feasibility study, we are studying design of material. We are selecting the material, and whatever the material we selected, whether it is okay or not, or whether it is able to perform that task or not. So this study is known as feasibility study. Apart from that, we are also considering the cost, volume and time. How much is the volume required and how much is the time? Suppose we are producing prototype, so how much volume we want to create. So this considered in feasibility study. So second is designing skill. For designing, we require some CAD skills also. So who is going to perform this? What are the skills? So for designing that particular object, we have some rough diagrams also. So that counts under designing skill. So okay, once we produce design, once we do feasibility study, cost, volume. So what is hardware required for that? So we are using here a 3D printer, whatever I shown to you in previous slide. So this is hardware we are using for producing 3D printing objects. Okay. Now CAD softwares, which CAD software we are particularly used for producing 3D printed object? So NX, AutoCAD, Inventor, these three softwares basically we are using for producing the 3D printed object. Now, okay, feasibility study done, design done, we selected 3D printer, we selected one of CAD software also. So, which material? So, raw material we can use, I already told you, plastic or metal we can use. And then after selecting all that, we will going to select a project setup. Okay. So, many people will ask the question, what is difference between 3D printing and additive manufacturing? So by considering 5 points, we can consider this 3D printing and additive manufacturing. So friends, we know 3D printing is the process of producing objects by putting layer by layer, plastic layer or metal layer on each other. Similarly, additive manufacturing also the same concept. It also deals with the same concept. Additive manufacturing, we can say एक लेयर पे दूसरा लेयर डाल के जो हम मेटल बनाते हैं या फिर ऑब्जेक्ट बनाते हैं, वी कैन से दैट दिस इज एडिटिव मैन्युफैक्चरिंग. ओके, सो 3D printing technology is basically used for producing only prototyping. While in additive manufacturing, we are using the same concept but in actual factory. Okay, are you getting my point? In additive manufacturing, we are whatever the objects produced are directly used in factory for operation. Suppose we are taking, I produce one nozzle 3 days before. So I will going to install that nozzle directly on my extinguisher. So in additive manufacturing, we are using objects directly in a particular machine or particular prototype. Okay, in 3D printing, this is only technology. This it means we are using for making toys or study only. Okay, so this is a basic difference between 3D printing and additive manufacturing. Now next, which methods they are using? In 3D printing, we are using fuse depositing modeling. Now what is fuse depositing modeling? When some metal is molten before putting into operation or before putting into the manufacturing, the material is fused. So, and that fused material deposited a layer one over another. So basically, we are saying that this is fused deposit manufacturing. Now, 3D printing deals with selective laser sintering. Okay. Now, what will happen in selective laser sintering? Simultaneously, they can able to produce the volume. Now, already we know 3D printing technology is used for real manufacturing. So, the volume is more over there. Now, If volume is more, then we require fast process. So SLS helps to produce number of objects in very short duration of time. Once you will need to set the program, I will add it that in detail selectively as a sintering in future slides, so we can see also there. Okay, so right now we will going to understand only what is FDM and what is SLS. So SLS is used in 3D manufacturing, additive manufacturing. FDM used in 3D printing. Next is which printers are used for producing. So in 3D printing, basically they are very using very common small printers or small desktop PC can also able to produce small design on CAD software. Okay, but in case of additive manufacturing, we require a professional or industrial printer over there to produce the object. Once upon time, last year we went in Ford Motors. So I saw a metal 3D printer, or we can say industrial printer. So they are producing prototypes for Ford Figo. You know Ford Figo car. In Ford Figo, for producing the dashboard, they are using industrial 3D printer. So the dashboard of Ford Figo new model are made by using industrial 3D printers over there. I saw in Sanand. Okay, so this is third difference. Now, fourth is what? Singular production, mass production, that we already covered. For producing single object, we are going to use 3D printer. For producing mass production simultaneously, if you want to produce a number of objects, then we are going for additive manufacturing. So now next is what? While we are producing object by using 3D printing now, so there is chances of mistakes are more, because this is a less accurate machine. While additive manufacturing, precision is matters more. We need to produce object very accurate, because after producing that object, as R&D, quality will approve that, operation will approve that. So high accuracy and precision is most important in additive manufacturing, because that object will directly going to install on the actual manufacturing process. So these are the five main difference between 3D printing and additive manufacturing. Uh, Likewise, basically, we can say in short, additive manufacturing deals with real modeling or real production, while 3D modeling or 3D printing is only deals with producing the prototypes or for study. Okay. So next slide is this is a block diagram. What is the process of 3D printing or additive manufacturing? Process is same for both. First of all, as we discussed, before producing object, we should have one CAD file. So whatever you want to design, you just produce it in CAD file. It means in CAD, in Emacs, in SolidWorks, in Inventor. Whatever you want, you need to prepare a GA drawing, that is General Assembly drawing, or whatever you want to produce. So like that, we need to produce a one CAD file. So that CAD file, in next step, we are converting into STL. Okay, the stereolithographic technique, or AMF file. We are converting that file into STL. Now, what is STL? So STL defines only the particular object. Okay, in a space, we know we have XYZ coordinate. In XYZ coordinate, STL extract only the object. So we can say that like CAD file, this STL also one of software which defines the position orientation of particular object, design object. That's why we are converting that CAD file into STL file. Second thing, what is the purpose of a STL file? We can convert that STL file into another software also. It means if you have produced an object in AutoCAD, now you want to see in Inventor or in Unigraphics. So during conversion of STL, that a particular CAD software asks you in which software we will going to see this object. So we have one option over there. So by using that, we can simulate or we can visualize that STL file from AutoCAD to NX, from AutoCAD to Unigraphics, or from Unigraphics to Inventor, any one. So cross intersection will be possible in STL file. Now, next is what? We're going to slice that object. It means what? Computer decide how many layers are there. After producing STL, they will take an वो क्या बोलते हैं ना एक they will take that particular file into its operation and show us how much material is required. Okay, so we have one option over there in which pattern you require during slicing. If you want a triangular pattern, then they will show you a triangular pattern. If you want square pattern, it means that 3D printed object produced by number of small objects. If you select triangle, so again this object will produce by producing triangles, number of triangles on triangles, triangle on triangle, like that. So we say that this is a slicing technology. Okay, once you select proper slicing, then this again converted into G code. So friends, we know what is the purpose of G code. So G code will decide the moment of that particular extruder. Suppose M00, M11, M03, like that. Okay. So after slicing, that file is converted into G code, and that G code are directly transferred to the 3D printer. So 3D printer has its own CPU or its own memory. So these G code are directly fed into the 3D printer CPU. Now, after starting that CPU, after giving command from 3D printing CPU, actual process starts. Okay, I will again explaining CAD file. We have produced CAD file, then it converted into STL, then STL converted into slicing for deciding which pattern we want. Then this all these are converted into G code. G code are required for what? In which moment particular object will produce, or which moment required. Okay, that we don't need to feed any manual part programming over there. This machine will do all these things automatically. Okay, so this is a basic process of producing 3D printed objects. Now, next is software used for slicing. Now, similarly, as we know, for CAD we are using AutoCAD, Inventor, Unigraphics. For slicing, there are particular or specific software. So these are Cura, then 3D printer OS, and Octoprint. So mostly industry people are using Cura for slicing objects. Okay, and 3D printer OS is also used, but this is particularly in education industry. And slicer, while we are going producing objects to metal printing, then we are using slicer also over there. Okay, friends. Now next, which material? Raw material. So this is in picture you can see. As I already told you, objects are made by using plastic or metal. So in plastic, again, there are a lot of types of material. So this is ABS. ABS is used where we need to produce a bodywork of cars. While we are producing parts for cars, then we will going to use ABS. Okay. Then for mobile phone also we are using this ABS also. Okay. So where it is used when we required a induction hardening in which range from 230 to 260 degree, or if you want to produce a very tough material, then we are going to use ABS. Okay, so this is a particular material which is used for producing the bodywork of cars. As I already told you, in Ford we saw a 3D printer which produces the dashboard of Ford Figo model. So next, apart from that, we are producing 3D models also by using nylon. So friends, this is a nylon. By using nylon, we can produce object also. In second picture, you can see we can produce the objects uh, which are flexible. So this is a flexible spring which we can use in water, or this is not dissolvable water. particularly what will happen sometimes material going to dissolve in water or in chemical. So industry person particularly when you are discussing with polypropylene material, so this is a not dissolved in water, so this can work in water also, particularly in submarine operation. We are producing 3D printers by using this material. Then in third frame picture you can see the composite material. So in composite we are using plastic as well as metal for producing the 3D printed object. Okay, and next is hybrid material or aluminite material. Now, what is hybrid material? In hybrid material, we are going to decide a particular percentage of that material. It means we need to use 70% aluminum, we need to use 30% plastic, 10% this. Okay, so in hybrid, basically we have all the uh, percentage, we have all the percentage available with us in hybrid material. Okay, so we can say that this is hybrid material. In composite, simultaneously we are using the material, but we don't have a particular percentage over there. How much percentage we are going to use? Okay. Next is which are the uh, technology, 3D printing technology. So I already explained you a BIM, that is a fuse deposition modeling, which is use plastic or wire extrusion over there. Now next is CFR. Hello, am I audible, sir? Hello, 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 hello. Okay, I think I'm audible to all. Okay.
You are audible, sir.
So I need to check. Okay.
Okay, sir. Okay,
Uh,
sir.
ha, ha, ha. Uh, I think I started from first. Okay. So FBM we already discussed, that is fuse deposition method, sir. Okay. So this is continuous fiber reinforcement. In continuous fiber reinforcement, we are using carbon fiber extrusion. So carbon fiber extrusion is a technique in which we are extruding the carbon fiber through a particular die. Okay, it means if you want to make a wire, 3D printed wire. Okay, so this carbon fiber extrusion technique is used. So by using this, we can produce a 3D printed wire. Okay, having circular cross section over there. So this technology is also used in industry for mass production of wire. So I saw the technology in RR cables whenever I was visited last year over there. Now next is atomic diffusion additive manufacturing, metal wire extrusion. So this technique is particularly used where we have to consider at small atom also. So while we are taking in fire industry, particularly when you want to produce a portable fire extinguisher, so at that time we need to consider this also. That is, it means a particular one object also will produce works over there. Okay, it means there. What is the chemical composition of that objects that matters. For that purpose, we are using atomic diffusion additive manufacturing. Okay. Now, selective laser sintering. Okay. In selective laser sintering, again I'm discussing you. This technology is used where we want produce a mass production. So this uses a laser to sinter. Now, what is sintering? Basically, this technology deals with hot roller. We are slicing the powder on hot bed. What I'm saying, we are slicing powder, metal powder, aluminum powder on hot bed, and we are applying laser beam on that hot bed. So laser beam will only select particular layers through which we want to produce the object. Okay, sintering means selecting particular powder and mold that powder to produce a particular one layer. Okay, so this is selective laser sintering. Once one layer is covered, then again these objects will move down. Again, powder will envelop on that surface of that object. Again, laser beam will applied over there. Again, second layer produced like that. SLS is used, is produced layer by layer. But in here, the material used for producing object is powder, not a plastic. Okay. In FDM, we are using fused material. Okay. In say SLS, we are using metal in powder form. Okay, direct metal laser sintering. Now, many times what will happen? Powder produce porous objects. So there is again chances of leaking. So we are producing direct metal laser sintering. It means we are using not using powder directly. We are cutting the objects. You know, in fabrication we are cutting the objects small, cutting the object or metal sheet in small pieces, or we can say this is works like laser cutting. Okay, so in direct metal laser sintering, metal powder fusion is applied. It means this directly cutting the object. Next is SLA, that is stereolithographic apparatus. So this is used in NASA for producing the robots over there. Okay, so what is the difference between SLA and SLS and FDM? SLA use directly STL file, not CAD file. Okay, so while we are some if robot or if some satellite sending some pictures through space on the Earth, so this software will directly convert that pictures into 3D objects. Okay, so this is one of the unique technology which grabs the picture, whatever sent from the satellite, and produce directly the object. Okay. Next is DLP. So this projector light curing resin. So this used for producing home household utensils. Okay. Projected light produces it's similar to SLS technology. Layer by layer we are using, but instead of laser, we can use other heat, other layers or other light for heating purpose over here. Okay. Next is supersonic 3D printing. So if we want to produce the object very fast, so this is a very advanced 3D deposition technology. Simultaneously, this produces number of objects during one batch. It means in other technology we are producing only one object, but in supersonic 3D deposition we are using number of extruders. Okay, simultaneously that extruder. If suppose one will produce a hand, one will produce something other parts. So the speed of this 3D deposition is much more as compared to other above process. So that's why we are saying that this is 3D deposition process. Now, one more thing I would like to explain you. You can observe here uh, this all this technology produces the object of single color only. Okay, so some might have this question also कि sir आप जो बोल रहे हो तो ये single color का ही बनाएगा. So this is no. I will give you the answer. We can produce number of objects by using number of colors and number of materials also. So for that purpose also we have unique 3D printers available in the market. So they are using a different like our a plotter, or we know the this color printer, like that. These colors of plastic or filament stored in the memory of 3D printer, and they will select a particular color, and we can produce a colored 3D object over there. So this all this covered under direct energy deposition. It means laser plus metal and melting. So apart from all the technology, DED is a very unique technology. So in DED we can produce any object by using any color, whatever you want. Okay. So these are the techniques by using we can produce in 3D printing. Now my main object of this uh, seminar is what is the need, what is need of this 3D printing. So I grabbed this points to explain what is need of 3D printing. So friends, before 3D printing technology, what was happened? Just people are thinking, design engineers are thinking, I want this object, but they are not able to produce the object. Suppose we are taking the example of Ratan Tata. So they don't have that much time to visually see the design on a sheet. Okay, so what industry persons do? They are just producing the. त्यांना सांगा थोडा वेळ बोलू नका, माझं खूप इम्पॉर्टंट प्रेझेंटेशन चाललंय. So they are producing objects and show to the chairman or the plant head, sir, this is the concept. Our final object look like this. हमारा जो ऑब्जेक्ट है वो इस तरह का दिखेगा. Then that person will suggest the changes कि इसमें लाइट का पोजीशन कहाँ होना चाहिए, क्या होना चाहिए, because they have a visual object or a real object. So they will say, Yogesh, you need to change this step. Yogesh, you need to change this. So engineer can save the time over there. Okay, because a lot of people don't have that much time to see your diagram. Or many times, what will everyone is not from mechanical background or from design background. They just interested to see your real object. Okay, so this is a need of 3D printing. First thing is what we can produce whatever we imagine. We can do whatever we imagine. Suppose we are producing single square in AutoCAD. So this is your imagination, but immediately by using 3D printer, you can produce this also. Okay. So it means this is a rapid prototyping or functional prototyping we can produce. I already given you one example. If I want to produce a nozzle, my boss 8 days before said me, we want a 4-hole nozzle. So how to produce? Because while for mass production we require die, we required particular dies for producing that nozzle. Again, cost of one die is more, which is not feasible. Okay, after producing the die or after making the die, if that object will not work, then again the cost of making die will go flush. So if we are using initially a 3D printed nozzle, so if it breaks now, then we have idea. Okay, at particular diameter, this is not okay, so we can change. So we don't require any die or we don't require any costly process to produce the object. Once we get the confidence, no, I can produce, मैं ये बना सकता हूँ, और my engineer if say no sir ये काम कर जाएगा, आप बनाओ इससे, then we are using this rapid prototype. Next is print on demand on site. It means some customers having different demands. Suppose some wants a different fixture, because every product having its own unique feature. So if customer want to change his own a little bit design, Then we have already stored 3D design in our computer. So as per each change, we will be changing some lines, some designs, and immediately we are producing that object by using 3D printer. So this is also a need of 3D printing. By using 3D printer, only we can produce print on demand or object on demand on site. Okay. Next is what? It reduces our inventory cost also. It means we don't need to store all these hard copies. Now in Corona time, who will see your hard copies? Okay, who will, because all we are working right now, we are work from home. So you can share directly a 3D object on the computer screen to the customer, and you show the step file GA drawing and this 3D printed file to the customer. Sir, this is like that. Okay, it means we don't need to invent. We don't need to store all the basic parts or raw material based on the customer demand, based on the design. We will produce the object. It means it saves your inventory cost, inventory space also. Okay, now next is this is strong but very lightweight parts. So for aerospace, for automobile, for medical application, before producing the, again this is the same concept. Uh, we are producing a particular objects for one or two or for 10 numbers. Then we are doing feasibility study, we are doing quality study, then operation team will validate it, R&D will validate it, and after all approval, we will produce the parts in actual manufacturing. Okay. Design and print, again this shorter manufacturing process. You can reduce your lead time also. Cost effective, less scrap, less manpower, and less energy consumption. Okay, so friends, this 3D printing technology reduces the load, or we can say reduces the human power also, manpower also. It means what? Before 10 years or before 5 years, before implementation of 3D printing technology, there was one R&D team, one quality team. So one engineer can produce right now on nowadays, out of 10 people, one engineer can do a job of draftsman. It means it can produce a design, it can validate, and it can see the operation also on factory. Okay, so this is a cost-effective process. Now, remote manufacturing. So I can send my design to my head office, HO also, sir, or my head office product manager. They can send me a different file from different customer, and they can inform me, Yogesh, I want such object. So what I will do, I will just convert this in STL file in my factory, and then do all the process, and I will just install that program into my 3D printer, and immediately I can produce that object of third party also. So this is a remote manufacturing. Friends, the reason behind taking this topic, need of 3D printing, is very essential because during my career with Parul University, or during my observation, I observed that whatever the technology industry using, and the students, they are less aware what is happening in industry, what they are learning. But Poonam ma'am and Bhovi sir have taken a good initiative to explain the students by inviting the industry persons what will happening in industry. So like me, the peoples will going to introduce the students what are the industry expectation, and what we are learning. So this webinar series particularly bridges the gap between industry and academia. So this, by taking this knowledge, we can simply say that that particular attendee can able to imagine what will happening in industry and what industry expectation from the students. Okay, so this is a need of 3D printing, friends. Also during your study, you have to focus all these things. One channel is there available over there. That is interesting engineering. So you go on YouTube and you search. So you can see a lot of videos on 3D printers, and there is a lot of information available on 3D printing also. Now, next point is what? I am 10 years of experience in industry and teaching also. So I met many people in my professional life. Conducted many industry meet also in Vadodara, in Mumbai. So industry 4.0 particular deal with this 3D printing and additive manufacturing. One of my friend who worked with Philips Tools or Philips Tool India Private Limited. One is in Homley. So they are in dealing with this 3D printing technology. And one MacForge University. So they are supplying the industry 3D printers to the industry. Okay. So a lot of organization, a lot of industries will come in front to help other industry for this 3D printing. I already given you example of Ford Motors and already given you example of Tata Motors. So like that, other small scale industries, SME industries also started this 3D printing before producing any objects. So my only intent is, friends, to explain you what is need of 3D printing. So this saves your time, cost, and headache, and also you can produce number of objects. If small changes you want to do now, so you can design and produce part in very less duration of time, and there is a very demand of such a design engineer in market. Friends, if you have a good knowledge of CAD software, if you have a good knowledge of 3D printers, so any MNC group, any small scale industry will hire you and they will give you a good package based on your knowledge and experience. Next is what 3D printer hardware. How who can use this 3D printer? We already told you during this entire process, only one hardware we are using, that is 3D printing. Rest of positions or rest of things are done only by the computer. Next is hobby. Some people are using this 3D printer because they have hobby to produce the toy. They have habit to produce different interior design. So I met also a lot of interior designs in Vadodara. So they are producing objects. If you want to showcase your hall, if you want to showcase your bedroom, so you can use these 3D printed objects. So these toys also you can make. Okay. Next is professional and functional prototype that we already discussed. Whatever the discussion happened till that was total professional and industrial. Okay. In professional and industrial, what is the difference? In professional, 3D printing plus additive manufacturing covered. In industrial, only functional parts are covered. Okay. So this is industrial and functional parts. Now raw material I already explained you, ABS, nylon, plastic. So a lot of material we can use for using producing the 3D printer, 3D printed objects. Now, friends, next in 3D printing in education, particularly I taken this slide because I am giving seminar to the students. Creativity and design skills are required. Design, check feasibility study and manufacture. DFAM, design, feasibility and manufacturing. डिजाइन करो, उसका फिजिबिलिटी करो, फिर उसको क्या करो, प्रोड्यूस करो. Okay, so if someone is interested really to make his career, so they can adapt. This is my particular suggestion. They should use this DFM technique. Collaborating problem solving skill, 3D printer setup and 3D strategies. In the industry 4.0, I already conducted one industry meet in Hotel Express Tower. So one of our team in ITM IT Blue Lab, they shown us a dancing robot. Okay, so this problem solving skill, it means they produce one dancing robot and one pick and place robot. So for doing Ganpati Bappa Aarti, they produce 3D printed robot. What I'm saying, they produce 3D printed robot. All the parts are made by 3D printing, and only the motor is of aluminum. Okay. Then STEM education in Lego robotics prototypes scale models. We can use this. Okay. Now next is visual and practical learning with 3D printed objects. Okay, you can visual and learn by using this 3D printing objects. Core learning now, particular engineering teachers are also show this 3D printed models to the students. So that should be a greater understanding for the students. Next is 3D model design, print the object, engaging the learning experience. So many universities also giving this practical or incorporated practicals of 3D printed in his syllabus. Babaria Institute of Technology, I saw that over there in Vimal Bhair. They are giving this same training to his blue tech engineers or blue collar engineers. Blue collar engineers, you know, friends, who did this ITI but not did a diploma. Okay, 5 मिनिटं फक्त आता आपल्याला ठीक आहे सो this is engineering and learning experience and this blue collar engineers they are not able to learn not read your designs in English but they are the actual manufacturers or real heroes who are making the objects. So you can give one 3D printed objects to him for his better understanding. Sir, I want to produce this. So they have a better understanding they what they want to produce and they will take a dimension according to that. Okay. Now any question anyone have? Hello. Hello.
Uh, Thank you so
Huh.
much, sir, Yogesh Patil, sir,
Huh.
for your wonderful session.
Hmm.
If any doubt,
Yeah.
students, please contact
Hmm.
me on my email ID,
Yeah.
umeshkumar.wasawa@Parul University. Okay.
Okay. Okay.
Yogesh, sir, I will forward students' doubt on your email ID.
Okay.
Okay, sir?
Okay, sir.
Okay. Thank you so much,
Oh,
sir, for your
okay.
wonderful session.
Okay, sir. Thank you. Bye. Okay.
Uh, Sergi, hello, sir.